Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, Prof. Fuad and my dear friends. In this occasion, I would like to present my understanding on reliability, dependability, and unidimensionality. Well, to my understanding, this chapter is quite complex. It deals much with statistical procedures. It deals with formulas, numbers, and other statistical calculations. So I do hope that by the end of this presentation, I would like to invite some insights, and also I do hope that we will have more discussion about the chapter, because I think we need more discussions about this. Okay, based on what I have read, there are three central issues related to the chapter. The first one is reliability in NRT, the second one is dependability in CRT, and the third one is IRT consistency issues. Before we begin our first topic, I would like to deliver the preliminary definitions. First, it is about individual variability in performance. I think it is generally acknowledged that everyone has different performance in taking the test. Learning from our own experience, we have experienced that sometimes we get A, B, C, and even we fail in our exam or any kind of test. So there must be factors influencing our performance in the test. Therefore, there are external and also internal factors of the variations. For external factors, it deals with any physical situations or condition around the examinee. It can be in form of weather or the condition of the test where the examinee is taking the test. For internal factors, it is related to the internal condition of the examinee. It can be in form of mood or motivation. Regardless to the external and internal factors, so variations in examiner's performance in the test is relatively acceptable and normal. Okay, so and then for other definitions related to reliability and dependability, reliability is used with a reference to consistency in NRT, while dependability is used with reference to consistency in CRT. We are going to talk more about this in the next discussion. Before we talk about NRT reliability, I would like to define the NRT reliability, and also I would like to talk about the underlying theory. Well, NRT reliability is defined as the proportion of observed score variance that is true score variance. Or in other way, we can say that the true score variance being the proportion of observed score variance that is without error. The underlying theories behind the NRT reliability, we know that test scores are assumed to vary around the test mean in such a way that the relative status of each examinee can be determined in relation to this variance. So NRT reliability focuses on specifying the variance component for persons and error in order to rank individuals for relative judgments and also decisions. Now we begin with the first topic, which is reliability in NRT. When we talk about reliability in NRT, we talk about node and correlation, test-retest reliability, equivalent forms reliability, and also internal consistency. When we talk about a node on correlation, we are talking about how an item relates to the total test score, or whether an examinee who gets a particular item correct is classified into master, while the other one who get the item incorrect classified into non-master. In test-retest reliability, it examines the consistency of a test over time. However, it is seldom used in language testing due to its potential problems related to the correlation of two test administrations. In equivalent forms reliability, different forms of a test are constructed to measure the same construct, sometimes consisting of items from a larger item pool, administered to the same examinees, and the correlation coefficient between the score is interpreted as a reliability estimate. For internal consistency, it examines how different parts of a single test relate to each other, how two halves of a test correlate, estimate the average correlation among all individual items on the test across all the examinees, whether parts of a test behave in the same way in terms of ranking the examinees. Talking about a note on correlation, we are going to be familiar with the terms of person-product moment correlation, degrees of freedom, and also correlation coefficient. Well, NRT reliability is estimated by determining the extent to which variables cover, that is, whether two forms of a test order the examinees in the same way, whether the same test orders the examinees in the same way over two different administrations, or whether examinees are ordered in the same way across all the different test items. So it deals with ordering the examinees based on the test they take. In test-retest reliability, the terms would be about equal means, equal variances, and also equal correlation with external criterion. Test-retest reliability examines the consistency of a test over time. So the correlation of the scores between the two administrations indicates the reliability of the test. And for equivalent forms reliability, this reliability is proposed to avoid the problems with content contamination happened in test-retest reliability. So to calculate the equivalent forms reliability, the two forms of tests are administered to the same examinees, and then the correlation coefficient between the score is interpreted as the reliability. So it is particularly of interest in settings which have clear objectives and item specifications that are used to generate test items, and it provides some indication about the stability of the attributes that are being tested. Again, we are going to deal with equal variances and also equal correlation when we are talking about equivalent forms reliability. To get the internal consistency of our test, we may use split half reliability, alpha, KR20, KR21, and also the standard error of measurement. In split half reliability, the tests are divided into two halves, and then the scoring is done by numbering the items into odd and even, and then the calculation is made between the correlation of the two halves to get its reliability. And to get stronger reliability, we can use alpha, KR20, and KR21. Why is it stronger? Because the interrelationship among all of the test items are calculated. And don't forget also about the standard error of measurement, because it represents the confidence of the interval, the interval of the examiner's score. So it deals with the normal distribution of the errors in our test. So in that way that we can get the internal consistency of our test. Now we continue to the second topic. It is about dependability in CRT. With this discussion, we are going to talk about threshold loss agreement methods, generalizability theory related to domain score dependability, and also squared error loss dependability. And we also talk about useful relationships among reliability and dependability indexes. With threshold loss agreement methods, the examinees are classified into masters and non-masters, and they are classified by calculating the coefficients. In generalizability theory, or in short we can say this as G theory, when it is related to domain score dependability, so it is related to generalizing the specific sample by means of a set of clearly defined estimation procedures. While when it is related to squared error loss dependability, well, it is related to the sensitivity of the degree of mastery and non-mastery, and also the misclassifying of the individuals into the two classifications. And for reliability and dependability indexes, they are calculated with KR20 and KR21, and the useful relationships among them. We can interpret the result of the calculation as low or high conservative estimates. In threshold loss agreement methods, the examinees are classified into 4 types. The first type is type A. It is for those who master on both administration of the test. And then type B is for those who master on the first administration but a non-master on the second administration. Type C is for those who is a non-master on the first administration and master on the second administration. And type D is for those who is a non-master on both administrations. Generalizability theory, or G theory, is used to help in improving the reliability of language tests. It can be used in reading comprehension tests, writing tests, and also oral proficiency tests. It can also be used to estimate score of dependability in criterion reference language tests. G theory is also used to study the variability in test task and rated judgments on a speaking test. The analysis we used is ANOVA, and with this analysis we are going to deal with the terms of G coefficient and also confidence interval. Now we come to the last topic of our discussion. It is about item response theory, or IRT consistency issues. In this discussion, we talk about unidimensionality, local independence, and model to data fit. The definitions of unidimensionality are typically abstract and non-operational. A set of test items is unidimensional when a single trait can explain or account for examinees' test performance. When ability is held constant across examinees, the responses are statistically independent of one another. The only factors affecting examinees' responses are their abilities on the latent trait. Related to model to data fit, it involves determining whether the appropriate IRT model has been selected. The determination is a process of judging the fit of item and examining behaviors to what the selected model would predict them to be. Now we come to the last section of this presentation. It is about the conclusion. I would like to conclude that while IRT is as concerned with consistency as the NRT and CRT frameworks, the way in which consistency is approached is different. The focus is on consistency of response patterns and consistency of obtaining actual observed values that are close to predicted values, given information about examining ability and item difficulty. A central feature of the concern with consistency in IRT is the extent to which the ability and difficulty estimates are invariant across specific items or test samples. So if CRT tests are to be constructed utilizing the advantages that IRT has to offer, a careful analysis of the issues mentioned regarding reliability, dependability, and unidimensionality will need to be conducted. To end this presentation, I would like to show you a quote I take from Brown and Hudson in the introduction. They say, "Tests are never perfect. it means that any set of test scores contains errors. In my personal view, I think that as a test developer, we need to do test and retest after we constructed our test items. Before the test items are delivered to the examinees, we need to make sure that the reliability of our test items fulfill the criterion of the good test. Well, I think that's all for my presentation. I do hope that I will get more and more insights from you, and we will have more discussion on the chapter I have presented to you. Thank you for watching. See you. Wassalamualaikum warahmatullahi wabarakatuh.